Hey everyone, in this video we're looking at scatterplots and correlation. We want to consider a scatterplot whenever we're looking at paired or bivariate data. So these are two quantitative variables that are linked in some way. Some examples from our text are a vehicle's age and the gas mileage. So each vehicle we could record how old it is in years and what its gas mileage is in miles per gallon or something similar. Or student study time and exam scores. So every student has an amount of time that they studied and an exam score. The third example is rental price and square footage. So if I consider one of these examples, vehicle age and gas mileage, what a scatterplot would show is two axes where each axis represents one of these variables. So maybe vehicle age is my horizontal axis and gas mileage is on my vertical axis. In many cases, you could flip-flop and put either variable on either axis, but we're going to want our explanatory variable to be on the x-axis. This is where we would normally put the independent variable. So in statistics, we call this the explanatory variable. And then the vertical axis, or sort of the y values, would be the response variable. And these terms are referring to the fact that often there can be a relationship between these two different variables. So in this case, when a vehicle is older, so when its age is higher, usually that means that the vehicle gets worse gas mileage. So I might see vehicles on the higher age of the spectrum with lower gas mileage numbers, and then younger vehicles, newer vehicles, which would be towards the left on our graph, would generally get higher gas mileage. Now there's going to be variation in this because of course different sized vehicles, different types of vehicles get different gas mileage, but we would see kind of a general trend where older vehicles get lower gas mileage, newer vehicles get higher gas mileage. So in some sense, the age of a vehicle helps to explain what the gas mileage is or variations in the gas mileage. Now we call them explanatory and response variables. You can certainly create a scatter plot that doesn't show any kind of relationship between the two variables, but that's really what we're looking for when we look at a scatter plot. So if I saw a scatter plot that looked something like this, I would see sort of a negatively sloping trend line here where lower vehicle age is associated with higher gas mileage, higher vehicle age is associated with lower gas mileage. This is called a negative relationship or a negative correlation. Now, if I looked at real data here, the dots might not look exactly like my sketch, but we would see kind of that general down and to the right trend in a negative correlation. In comparison, if I looked at student study time and exam scores, I might see a graph that looks something like this. So I have the study time here on the horizontal axis between 0 and 16 hours in this example, and exam scores on the vertical axis. This particular data set was just randomly generated. This is not real data, but we might see something like this where students who studied lower amounts, we might expect that those students get lower test scores than students who studied for longer. So as we go from left to right, the dots go generally up. Again, this isn't going to be a perfect relationship because there are many different variables in what could cause an exam score. So if we're thinking about study time as an explanatory variable, how much you study could be one explanation or one factor in your exam score, but not the only one. And notice here as well that we have, for example, two students that both studied 5 hours, but got different exam scores. So they probably differed in things like prior knowledge, the quality of their study time, how much sleep they got, things like that. So that can explain other variation in the y or the response variable. Or similarly, we have two students with roughly the same test score. It looks like about 72 on this test. One studied 4 hours, one studied 9 hours. So you can have the same outcome for different study times as well. So it's not a perfect relationship, but we do see, in this case, what we would call a positive correlation. So on average, studying more time is associated with higher exam scores. So these first two examples, we had a negative correlation and a positive correlation. If I looked at rental price and square footage, I'm imagining a scatter plot, something like this. Maybe I have my square footage or square feet. Maybe I call this the area of an apartment or the size, and then the price. If I think about what I would expect for this relationship, apartments that are larger generally are going to cost more. So I would expect to see dots kind of scattered about up and to the right, following a line generally upward. So I would expect a positive association or a positive correlation here. In comparison, if I compared rental price and the floor number of a unit, I could also create a scatter plot here. If I had floor as my explanatory variable and price, I could take each apartment and say what floor it's on. Maybe lots of them are on the first floor, and we have lots of different prices. And then we have second floor. We'd probably see what we call some banding in this data, since the floor has to be a whole number and there's not that many options. But I actually wouldn't really expect much of a relationship between what floor a unit is on and the price. Now you could look at real data to see if there is a relationship, and maybe, units on the top floor of a high rise might be more expensive, being penthouses or something like that. But for the most part, there probably isn't much relationship between the price of an apartment and what floor it's on. And so this would probably be considered no correlation or no association. Just like paired data can sometimes not have correlation, not all data that comes in pairs is really paired. So just because you have X values and Y values, or two numerical data sets, doesn't always mean that this is paired data, and it doesn't always mean that we would want to look at a scatter plot. So for example, if I had a list of X values that were test scores for men and a list of Y values that were test scores for women from the same test, this is data that is sort of linked together. They're both data values from the same test, and it might be data that we want to compare, but this is not paired data, because each of these test scores for men doesn't line up with a particular test score for women. You could think about, you could totally reorganize or resort your X values and keep the Y values the same, and it would still make the same amount of sense. So these are not linked one by one, even though they're from the same context. So we would not do a scatter plot for this. It just wouldn't make sense. In the second example here, I have X is test scores for a class before a concept was taught, so scores on like a pretest, and Y is test scores from a class after the concept was taught. So this is test scores again, but these are paired data because each test score is from, each X value and Y value would be from a single person. So if I had my little scatter plot here and I had my X's and my Y's, one point on here would be the X coordinate would be the pre-test score for that student. The Y coordinate would be the post-test score for the same student. So it would make sense to create a scatter plot here. But correlation isn't really the question that I'd be most interested in this example. So while you could look at the correlation, hopefully people who scored high on the pretest also scored higher on the post-test. So I would expect to see some positive correlation here. But the correlation would not be the most interesting question. Really, we would want to look at how much did each individual score go up. So you'd probably want to do some kind of subtraction between these values to see the score increase. Or maybe consider the mean of the X values and the mean of the Y values or something like that. So this is paired data, but correlation might not be the most relevant question. In my third example here, I have X is test scores on a math exam, and Y is the starting salary in thousands of dollars for the same person. So since these X's and Y's are linked again by the same person, we can think about creating a scatter plot, and a point on that scatter plot would represent the X score would be their math score, and the Y value would be their salary in thousands. So each dot would represent one person. These two values might not immediately seem to be related because one is about a math exam and one is about salary. But we would actually expect to see some amount of positive correlation here because, just statistically speaking, students who do better in math tests or math classes do tend to have higher salaries. And there might be lots of reasons why this is. Probably one of them is that students who go further on in math might choose more technical careers like engineering or science or something like that tend to pay more. Now, this correlation is not going to be super tight. There's not a direct relationship between your math exam score and your starting salary, but we might expect to see a general kind of upward trend among data of this type. And so the scatter plot, if we looked at some actual data, would be a way to help us see what kind of relationship we have there, if it's positive or negative, or if there's no correlation. So let's look at actually creating a scatter plot. So I have just a small data set here as an example. We have the hours of sunshine per day and the ice cream sold. So our sunshine hours are 3, 5, 6, 8, 9, and 10. These are sorted by the amount of sunshine in this case. And the corresponding ice cream sold, 28, 40, 52, 61, 70, and 65. The units here are a little bit vague. I don't know if these are individual servings sold, maybe at a relatively small shop, but we're just using this as an example. So I'm going to show you how to create a scatter plot in Excel. I would want to either copy this data or just type it into an Excel file. So here I have my data set in Excel. And scatter plots are actually really easy to make in Excel. So I want to put the data side by side. I have them in vertical columns. So my sunshine hours are in column A, and my ice cream values are in column B. And I'm going to highlight both columns together. So here I have highlighted from A1 to B7. That includes my labels. You don't have to have labels, but it's good to label your data in the Excel file. And then I'm going to go to the Insert menu, which is where all of our charts live. And in the Charts section, towards the middle at the bottom, there's Insert Scatter X, Y, or Bubble Chart. And the icon is like 2 axes with some dots on it. And I'm going to choose just this first option, a scatter plot. If I look at the first, the lower left dot here, this is the point 3, 28. So that represents a day where there was 3 hours of sunshine and the amount of ice cream sold was 28 servings maybe. In order to make this a good scatter plot, I do need to add labels to the 2 axes. Otherwise, someone looking at the graph wouldn't know what any of these numbers were. So I'm going to go to the Chart Design tab. If you don't see that, make sure you've clicked on the graph. And under Add Chart Element, I want to go to Axis Titles, and I'm going to add both the primary horizontal and the primary vertical axis titles. So my horizontal axis in this case is the sunshine in hours. You always want to include units if you can. And I know that these are the hours of sunshine based on the size of the numbers, but this horizontal axis will always be the first column. So if you wanted to switch the 2 axes, you could just copy and paste the columns in the other order. Our vertical axis is going to be ice cream sold. And I'm going to say that this is servings. Just a guess. And then for the title of the graph, you want to give some explanation of the context. So often this will be something like sunshine versus ice cream sales. And you might also include like in Colorado, or if there was some kind of context that the reader would need to know about. So we've got labels to tell us what the graph, what the data is representing. And I can look at these dots and see that we have a positive relationship or a positive correlation because the dots sort of go up and to the right. If I was going to draw in a line of best fit, it is sloping upward to the right. And these dots also form pretty closely to a line. So this is probably a pretty strong linear relationship. That's really all there is for creating scatter plots. In the next video, we'll talk about how to actually measure how strong that relationship is, to measure the correlation among points on a scatter plot like this. I did also want to show one other example. I have here some data on essentially every school or child care center in Colorado from the CDPHE. I have the enrollment for that school and then the percent of the students who are vaccinated. So this is a very large data set. There are, I think, even thousands, at least hundreds, if not thousands of schools that are included in this data set. But if I wanted to do a correlation or a scatter plot to see if there's a relationship between the enrollment or the size of the school and what percent of those students who are vaccinated, I can highlight my two columns and with just the same number of clicks, insert a scatter plot. It'll take a minute because this is a very large data set, but Excel will just kind of spit out my scatter plot here. This is kind of an interesting pattern. So we have the enrollment along the x-axis and the percent vaccinated. You can see that these values are limited from 0 to 100. We have a few quite large schools and then lots of schools that are smaller. This particular scatter plot is a little hard to read because there's so many dots, and there are some different modifications you can do with graphs for really large data sets that we won't get into. But we do kind of see an interesting pattern where the larger the school is, it actually seems to be more likely that the vaccination rate is either very high or very low. There's not a lot of middle vaccination rates in when the schools get larger. Interesting feature. We don't see a particular correlation here. I don't see a trend upward or downward in this data. So I see sort of some non-correlation or non-linear trends in the data that are kind of interesting. But I just wanted to show that Excel can do scatter plots for larger data sets as well. That's it for this video. You can check the next video to find out about the correlation coefficient and how we measure correlation. Thanks for watching.